Okay, so I will just start and have people still coming in. So welcome everyone to today's webinar on locating offshore wind in Australia. We are very happy that we have today's speaker, Sven Teske here. And we also have Peter Cochrane. I will introduce both of them in a few minutes. Before we get started, I just want to share our normal housekeeping rules here at Ginger. If you can, and if your internet connection allows, since we're also not so many people, it would be great to have the camera on so we can see your faces, especially later when we discuss. But please have the microphone off when you talk, when you don't talk. Also, it would be great if you could rename yourself so we know from which organization you are. If you have questions, we will have a Q&A session at the end. So please, during the lecture, you can already start to drop your questions into the chat box. The session is recorded, as you have already noticed. This is mainly due to the reason that some people don't have time today, so they can have a look at the recording later. And yes, again, welcome everyone. While I go on with my slides, it would be nice to hear from you where you are actually based and from where you are connecting with us today. So please write your institution and maybe country or work residence into the chat box so we kind of have an overview who our audience is today. These are our speakers today. We have Peter Cochrane here. Peter has a lot of roles. I looked through your biography. I will not read them all at the moment. You're a very active person, so thanks for joining us today, Peter. He has over 20 years of senior executive leadership experience across public and private sectors, with a very strong focus on the environment and sustainability. He is a counselor and vice president of the International Union for Conservation of Nature, IUCN. Peter is also a member of the Australian Heritage Council, and chairs the Australian Tropical Herbarium Board and the National Benefit Assessment Committee of the Marine National Facility. And you're also a director of Ocean Earth Foundation. I will stop here because I think you're already very, very busy. Thanks for joining, Peter, today. Peter will give us set the stage a little bit later. And then I'm happy to have Sven on board, who is actually working in Sydney at the University of Technology, but he's dialing in from Hamburg, Germany today. And he's a professor and research director at the Institute for Sustainable Futures, but we will learn a little bit more about you later. Just quickly our agenda. So I will briefly introduce Ginger to you. Then we will have setting the stage by Peter, and then we will learn more about locating offshore wind in Australia. And as I said, at the end, we have 15 minutes minimum to answer your questions. So I will make this quick because I know some people have joined our recent webinars on Ginger, but for those of you who are new, so Ginger is a very new initiative. It's called the Global Initiative for Nature, Grids and Renewables. And why have we decided to come up with Ginger? Because we face a triple challenge, very obvious to many of us here today, looking at the hottest temperatures in Germany, beginning of July ever measured. The same Peter just told us what's going on in Australia at the moment. So climate change is real. And the biodiversity crisis, on the other hand, is real as well. So we need to think both things together. And last but not least, we also want to integrate the communities and the people. And this is why RGI has, together with the International Union for Conservation of Nature, IUCN, teamed up and initiated Ginger. We were officially launched at the COP28 in Dubai. And what are we actually trying to do? We are working on assessment tools, basically trying to find the metrics that we need to measure the biodiversity impact and the contributions to nature when building renewable infrastructure. Just a few words. If you have any concrete questions about Ginger, I'm happy to answer them later via email. We don't have much time for this today. If you're interested, please drop us an email. We work with a very collaborative mindset, meaning that we work with different technical working groups and include a lot of different stakeholders from academia, from civil society, and from industry. And we really want to go beyond setting only principles. We want to help governments and industry to introduce metrics that then can be used when deploying new infrastructure, meaning in this case offshore wind, but also onshore wind, grid infrastructure, and solar. Just a few words on who we are. So I'm working together with my colleague Aston at the Renewables Grid Initiative. We are based in Berlin. And just a very short introduction, you can see a lot of logos. If you're not from Europe, you might not know them all. So basically, what is RGI doing? We are a unique collaboration of different NGOs and transmission system operators, basically bringing both of them on one table. And together, we are aiming for full decarbonization, fair, transparent use of grid infrastructure, sustainable grid development. Then we have IUCN. I'm not going into the full detail of IUCN because IUCN is a very, very big membership union bringing together governments, civil societies, organizations, and a lot of other stakeholders. They have very critical and important expert commissions. You can see here on the right. And the mission of IUCN is to influence, encourage, and assist societies to conserve nature's integrity and diversity, ensuring sustainable use of natural resources. And you can see we're a very different kind of partners. RGI, very small, very European, and IUCN having all the data, having all the important members. So we really hope we can move something in this context. This is how Ginger is working. We have active working groups. We have one metrics working group, which is led by IUCN, because they are the experts in the field of data acknowledgement and databases. Biodiversity data, especially habitat data. Then we have the offshore working group, which is led by the NGO Ocean Conservancy. Then we have the linear infrastructure working group, who is led by RGI, by my colleagues. And we have now started a new people positive working group, which is led by Stockholm Environmental Institute. And we are planning to have a monitoring and a reporting working group. But without further ado, this is not about Ginger today. If you have any questions, please drop us an email, check out our website. And then I will actually be happy to give the word to Peter to give us a little bit of an introduction and set the stage. I will just stop sharing my screen. And thanks for being with us also at a later hour than for most of us here today, Peter. We really appreciate it.
Thanks, Annika. So it's a fantastic opportunity here to talk about how the issues that arise from decarbonisation and a just energy transition intersects with our concerns on nature loss, recovery, and ideally moving to a more nature positive future. So IUCN has been traditionally involved, as its title says, on nature conservation. But as the global pressures on nature increase and intensify, and climate change becomes ever more of a issue of intense concern, we've increased our focus a lot now on climate change, and in particular the energy transition. And Annika read out our mission, but let me start with our vision, which is of a just world that values and conserves nature. And so when we turn our mind to energy and energy transition, we are absolutely talking about a just transition that reflects our deep concern for nature and people. So that background, I think, is really important because our objectives with working with the renewable energy sector are to overcome barriers to the rollout of renewable energy, to ensure that this transition to renewable energy does not come at the expense of biodiversity. And there is increased access for marginalised communities as they adapt to climate change. And this requires everyone involved, companies, regulators, civil society, and organisations like IUCN and the Renewable Grids Initiative to work together towards a nature and people positive role for renewable energy. So where we are in Australia is there's a rapid rollout of solar. less rapid, but still nonetheless very positive rollout on onshore wind, and offshore wind is in prospect for us. And I'm delighted that we've got Sven to take us through the issues that arise with that come up for both regulators, governments, civil societies, local communities, and nature and environment organisations such as ours. It's a wonderfully complex issue. Australia is blessed with opportunities for this, but there are a number of obstacles and barriers to realising this. So it's in prospect for Australia. And I'm looking forward to hearing from Sven's experience in this and his particular study of the opportunities and barriers to offshore wind in Australia. I'm going to leave it there because Sven is the expert here, not me. I'm happy to be involved in any questions that might arise in terms of that intersection of renewable energy and nature. But please, if you'd welcome Sven, over to you. Thanks.
Thanks, Peter. I'm going to share my presentation. Is that, you see the presentation?
Yep.
Good. Yeah, my name is Sven Teske, and as you probably hear from my accent and my name, I'm not originally Australian. I immigrated to Australia over 10 years ago. I'm now Australian and German citizen. I'm originally from the North Sea coast, and I was involved in the offshore wind debate in the very early stage in the 90s and early 2000s in Scandinavia and in the North Sea area of Germany and the Netherlands. So basically, from my history, I basically witnessed already one debate about establishing a new industry in an ocean environment where there was nothing. Because Germany, for example, has no oil and gas industry in the North Sea. So it was a very different situation. And professionally, I'm a professor at the Institute for Sustainable Futures at the University of Technology, Sydney. And my specialty is actually energy and electricity grid simulations and pathway for decarbonization. My focus is very technical and less sort of social or environmental or biodiversity focused. I'm very much focused on the technology, so bear with me when I basically approach this from a rather technical point of view. So I start with the international context, and this photo here looks pretty much like Australia, just looking internationally and see what's possible. So none of the turbines are right now in Australia, but we look at the international context quite closely to learn from experience from almost 30 years of offshore wind on a global level. Just to recap, the first offshore wind farm was actually basically was a wind turbine with wet feet in Aarhus in Denmark in the late 80s, early 90s. They built 3 turbines, 500 kilowatts, and that was sort of the beginning. Now we have a very different situation. We basically have internationally already a number of installations. So this is from our analysis. We include offshore wind in our international and national climate mitigation pathways. We develop climate mitigation pathways for different countries, broken down then to over 20 industries. We have a bottom-up demand assessment for example, for the chemical industry and the aluminium and mining and stuff. And then we basically add up what we need in terms of energy demand, also forms of energy. Do we need electricity? Do we need fuels? Do we need heat? And then we come from the other side, from the generation side. So to put it in a context, why we advocate in favor of offshore wind for Australia is that it can add quite a good sort of additionality to compared to onshore wind and solar, and I will go into that in a minute. So the first publication we had was we based our projection to 2030 and 2050 on 2020 numbers. So at that time, we had 29,000 megawatts of offshore wind already installed. And we projected that this goes up by a factor of 100 until 1950. So only 5 years later, the total installed capacity globally moved from 29,000 to 83,000 megawatts. So that's a significant step. The majority of that was actually added in China, which jumped from 10 to 44. Offshore wind was originally designed and invented in Denmark, then moved to Germany and to the UK. And now it's spread to Asia, and North America is sort of slowly starting as well. So we're not starting from scratch in Australia. We actually can look around and see and learn from international experience. So here's the map for the different places where we model energy scenarios. All of them, all the countries with coastal areas have offshore wind in our energy scenarios. The global offshore wind capacity, which is projected until 2034, was just published a few days ago. In fact, I think late last week from the Global Wind Energy Council. And the projection is that between 2025 and 2035, 350 gigawatts will be added. Not total capacity, but 350,000 megawatts of new capacity will be built in the next 9 years. So that is quite a significant amount. So the potential for offshore wind in Australia was a research project 2 years ago with the University of Tasmania and Hobart and a number of industry players in a collaborative research. And this is the research team. So CSIRO was sort of, that's the Australian body, basically a body of scientific work. Then we had some industry corporations like the Blue Economy CRC. We also, for the just transition part, was the National Research Officer of the Maritime Union of Australia. And then we had those 3 colleagues of mine from the university, plus CETEC from Spain, who it's a company who specializes in floating offshore wind foundations. So just sort of top down, we just had a quick look on the wind regime in globally in Australia, and you see the more red you see, the stronger the winds. Obviously, around the north and the southern pole, South Pole, you have most wind. Australia is blessed with wind. Australia actually has better wind condition than the North Sea. So I think the first box is ticked. Do we actually have wind in Australia enough? Yes, we have. You see that we have the red more than 11 meters per second in the southern tip of Victoria, which is sort of south of Melbourne, in the southeast of the continent, where also Tasmania is, south of it. And that part is by far probably one of the world's best resources for offshore wind, with wind speeds on an annual average of 12 meters per second, which is really baseload. I mean, that is baseload. So offshore wind capacities and potentials are certainly there. So we looked at, in the first step, we looked at, do we have enough wind? Yes, we have. Second step, where do we have the best wind resources? And looked at the capacity factor. So as a rule of thumb, if you halve Australia, let's say you cut across from Brisbane, which is sort of in the middle of the east coast, and then on the, not really the middle, but almost, and then you just draw a line all the way to the west. Everything south of that is wind-wise very good. And also north, we have some areas where there's good wind resources. So basically, the second step in the search is, where could we locate offshore wind farms? The second step is the location of the water depth. As offshore wind obviously needs to be placed at sea. Currently, the majority of almost everything, more than 90% of offshore wind farms are actually seabed fixed. So they're located in the sea, but fixed to the sea bottom. The maximum you can do right now is around 50, 60 meters. We might be able to do a few more meters, but that is sort of the rule of thumb. Between 50 and 60 meters, that's what's the maximum for fixed offshore wind turbines. Everything else, if it's deeper than 60 meters, needs to be floating. But also floating offshore wind has a limit, and that is around 1,000 meters, which is already quite ambitious. I would say for the first practical steps, my recommendation would be not more than 250 or 300 meters, but 1,000 is possible, has been done with floating oil and gas rigs, especially in the Gulf of Mexico. So the floating oil rigs exist, and we basically use the same technology for offshore wind in that regard. So the first location, the priority for the first offshore wind project would be shallow water. The second, then deep water, between 60 and 1,000. But also shouldn't be far away from the land. So it should be less than 50 kilometers. The reason for that is quite obvious. You have staff, and you need to move equipment. If you have to go back and forth from the shore to offshore locations, and 50 kilometers is about 30 nautical miles roughly. And that means if you have a speedboat which has maybe 15 knots maximum speed, so you need 2 hours to get there. So basically, you don't want to have it too far away from the coast. There is another potential where you could go much further than 100 kilometers, but then you also have the logistical problems in moving not only the crew and parts, but also get a grid connection. Because the fourth criteria is I have a location for the wind farm. I have it is not too deep, and I have somehow a location on land where I can connect the wind farms. So basically, that reduces the number of possible sites quite significantly. Basically, in Australia, the grid connection points and the majority of the electricity infrastructure is around the east coast, all the way to the south coast around Adelaide. So that is it's called the National Electricity Market. Even though Adelaide is actually not in the part of it, it's connected to it. But this is basically the slim line along the east coast where the majority of the electricity is consumed and also produced. On the west coast of Australia, there is another grid. It's called the Swiss grid with one S, not with double S. That is around Perth. But the Western Australian grid is not connected to the East Coast. Also, in the north, Darwin, in the Northern Territories, the Northern Territories are not connected to any of the grids, so they basically have a standalone grids around the industrial areas and around the settlements. So they're not even part of it. So therefore, if you really scale down and sort of subtract all the barriers, you see that the actual places where you could start with offshore wind are quite limited, and they are around the existing fossil fuel industries, as there is strong infrastructure. So in terms of the grid, where the coal power plants are, for example, about 150 kilometers north of Sydney in the Newcastle area in Hunter Valley. Hunter Valley is basically one large area for the coal industry. There are very large substations very close to the shore, to the shoreline, which means you could actually connect the offshore wind farms from the sea straight to the existing interconnector and substations which were built for coal. That is also an advantage of against onshore wind, as onshore wind locations are quite often further inland, where there is actually no grid. So sometimes offshore wind is just more practical, as the grid is already there. There is one other additional requirement, and that is the port facilities. You need tugboats, you need supplier, you need a number of sort of vehicles, infrastructure to supply and maintain and build in the first place offshore wind farms. Therefore, you need quite a deep harbor. A shallow harbor wouldn't be suitable. So we're talking about 10, 15 meter water depth. That would be the best preferable port. And then you reduce the locations even further, as Australia has more than 15,000 kilometers of coastline, but not too many deep water harbors. So again, you end up where current coal industry and oil and gas industry is located. The data we used for this assessment was all on the meteorological conditions in the specific region. So we used the wind and solar data from existing wind farms and solar power plants in Australia within the same region, while offshore wind data was from meteorological data as well as from ships. As you can imagine, there's actually no real measurement at sea for the wind speed. What you do is you use the wind measurements from ships and then interpolate that like a ship's bridge from a container ship, for example, is about 30 meters above the sea level. But what you want is data 100 meters above sea level. So you have to have an interpolation, which adds a very high uncertainty, usually in the positive space, as the same happened in Germany 20 years ago. Then they installed an actual wind mast in the North Sea and realized that the wind was like 30 or 40% stronger than they expected. So basically, there is an uncertainty about the offshore wind measurement, as there is no actual measurement. Then we looked at the different nearby cities where we have possible wind locations, and we also looked at the transmission substations and the voltage level. As a very rough rule of thumb, you can say the voltage level is roughly the megawatt installed capacity plus, let's say, 20 or 30%. So for example, the Latrobe Valley, which is a coal mining area not too far away from Melbourne, it's Latrobe Valley. They have close to the shore. There is a link, a bus link. The bus link is a cable across the bus C, which is from Victoria to Tasmania. It's 330 kilovolts, which means it gives you around 500 megawatt of capacity you can actually install. Or that's the capacity you can connect to that cable for offshore wind. So we basically went through the different states and checked what's available. Then we put this all in a map, and that's sort of all the substations, all the different transmission lines. Then we spread the solar and onshore and offshore wind for the future, sort of the capacity we projected along those grid points. And then in the next step, we basically calculated the additional value of offshore wind. And I have to run you through that table. So in the Latrobe Valley, we estimate that we have about 1,000 megawatts within a 25-kilometer range of the coastline. We have an additional 1,000 megawatts further out until 50 kilometers, and another 1,000 megawatts in the third step, up to 100 kilometers. And then we calculated the potential electricity generation with the meteorological data we have. So you see, the further out you go, the higher the capacity factor. So the 0 to 25 kilometer offshore wind farm will have a capacity factor of about 45%, which means roughly half of the hours a year you get electricity out of that wind farm. And that goes up to almost 60% if you go further offshore. So you basically, the advantage of being further out is you have more electricity with the same installed capacity, because the wind turbines operate longer, many more hours. But the disadvantage is that you have to have more cable, traveling time back and forth for crew and material is much longer. So you need to check, is it worth the additional income in generation to have additional expenses on the logistical side, the material side. Then we compared this with the capacity factor on land. So here is the MacArthur wind farm, which is an existing wind farm in Victoria, which has a capacity factor which is basically more or less the same as the nearshore offshore wind. So that means nearshore offshore wind is definitely on land offshore wind is definitely much cheaper if you have a grid there. And then we looked at the solar utility scale solar power plant, and upscaled sort of their generation per kilowatt to 6 gigawatts installed capacity. So let's say we have the location around that existing wind farm, we increase the capacity. What will be the capacity factor? And then we, at the last step, we actually checked when over the year in hours will the generation appear. And I will skip this because that's the same for Newcastle. Otherwise, it will. I'm sort of. I don't have enough time for that. But that's the same idea of Newcastle. So we basically then put together the generation, and we checked over the year the worst week where we basically had the worst production in terms of renewables, and the best. In this example here, that's the Newcastle case. The black line is the load. That's measured load right now, and then we just upscaled it for a future projection. And then you see that there's a lot of white in between the yellow and blue, and that is unmet capacity. That is basically when the demand is the black line, and everything white is not met by everything we projected for solar and wind, which means if we have 100% renewables supply and we have no gas, coal, or hydropower. Hydropower is renewable, but it's not part of this here. If we don't have that, how do we actually generate that, or how do we get it with storage technologies? Not just batteries, but also maybe pumped hydro. And the other extreme, that's the lower panel, it shows that we produce almost the entire week far more electricity than we actually need. And then we have that red line below the zero line, which means negative demand, which is basically storage. So this is what we need in terms of storage. So the engineering job is, what is the optimal size for the storage in terms of capacity? So we always can meet the demand every second. And in terms of capacity in megawatt hours, that the storage technology, the battery or pumped hydro, will not be empty, and we still have not enough generation. So that is basically the exercise. And then the next part of the analysis is when do we have offshore wind, which is here in blue? When do we have onshore wind, that's green? And when do we have solar, that's yellow? And if all the circles would be identical, then offshore wind would not have any added value, because the offshore wind would produce exactly the same time as onshore wind and solar. But obviously, and that's quite obvious, that's not the case. So offshore wind is quite often available when there is no solar energy at night, but also no onshore wind. And that is a really good indicator if an offshore wind installation can add value to the electricity supply for and decarbonization, and that is actually the case. So that means if I have offshore wind installed, I also can reduce storage, as offshore wind can jump in straight away without taking electricity from storage if I just rely on solar and wind or onshore wind. So that is taken from an analysis we haven't done. That's from the project developer itself. That's from the Star of the South. You see the wind turbine symbol there on the right. So that's basically in the Bass Strait, so between Victoria and Tasmania. And that's also the furthest developed project currently in Australia. This is that shows what the additional value for the demand periods in the region would be, and that's sort of the turquoise line. So the Star of the South would add a lot of value to renewable generation when there is other renewable generation not available. So to zoom out now, we did this analysis just recently, a few months ago, for the entire NEM. You see the NEM here, and the NEM is broken down to different parts of the grid. And we also factored in the interconnection, for example, between northern New South Wales and southern Queensland, but also between Victoria and South Australia. So basically, we need to know if we can move electricity from one grid region to the other, and what would be the effect if we actually integrate offshore wind. We also looked at the current connection between the different states and grid areas and what's planned in the future. You see here in the fourth column, maximum capacity considered in the ISP. The ISP is an integrated strategy plan where the grid operator in Australia projects grid expansion for the next 10 years. The ISP is basically based on the earlier methodology from ENTSO-E, the European grid operator, which exercises the same thing for the 10-year network development plan, and every second year it's published. So basically Australia does the same for the Australian context to see where do we actually need to increase grid capacity or interconnections between different grid areas. And that is the same case, high week output. So the week of the highest renewable electricity output under our assumption for the installed capacity for 2030. And we already assumed we have about 2 gigawatts offshore wind in Australia and the NEM. That might be a bit too optimistic, but bear with me. You see that the offshore wind, which is the dark blue in the bottom, actually has sort of a base load function. And then we have between the two red lines, the minimum and the maximum. So there is quite a bit of peak electricity demand where we need to make sure that we don't run into curtailment. So we have not enough storage capacity. We don't have enough demand. So we basically have to shut down some generation, which will be lost then. We try to avoid that. That's the same for a low week output. Also for centralized generation, we also run a few cases where we have centralized versus decentralized generation, but I would take too long to explain that here, but that's another topic. But basically, we see that offshore wind integrates quite well. And I try to wrap up in terms of the situation. So we did, to wrap it up, we did an analysis, where can we do it technically, where can we do it logistically. As I said, we did not include the just transition in terms of stakeholder engagement and biodiversity. That's the next step. So offshore wind right now in Australia looks like that. There's nothing out there. That's June, and I took that photo last month in Australia, but there's nothing. But what we project is we have here all those projects. There is a website from Renew Economy where you can click through the different projects and click on a specific project and see where they are and what they plan. So this is basically the status. We have over 40 projects, and they're all in different stages. In 2024, we finally had 6 priority areas where the consultations are finished from the government. So we have one in the South Australia, the Southern Ocean. We have one in New South Wales, 2 in New South Wales. Hunter is north of Sydney, about 200 kilometers. Illawarra is about 100 south. Then we have the Indian Ocean Bunbury, which is just south of Perth. We have Bass Strait a region that's northern Tasmania. Gippsland, that's basically southeast of Melbourne. And they all have different priority areas. If I compare this with the situation in the North Sea, we are around the year 2000, where the project developer started by basically just putting a square somewhere in the North Sea and saying, I develop an offshore wind project. Then the government basically had a consultation process, and over 5, 6, 7 years, they come up with priority areas for offshore wind, which had to juggle national parks. Almost the entire coastline is a national park in Germany, shipping lanes, military zones, and then we had the offshore fields. That same happens in Australia right now, but we are not that far, so we don't have a full-blown license for any offshore wind farms. but we have visibility licenses across 6 projects, which are listed here. So we are coming closer to a situation where we might see a first offshore wind farm. I think if everything runs as planned, we could see the first wind turbine connected to the Australian grid before 2030. And with this, I close. That's a little internal promotion. We have a number of publications for free you can download, but I would stop here.
Thanks, Sven, for this very interesting insight for Australia. I learned a lot about the geography as well. I sometimes had to check where is which city again, but very, very great. I see there are some questions already, but I have like a more general question from the start, because you have done a lot of research on the One Earth climate model and Paris Agreement. You have a lot of knowledge there. In general, because we have a very global audience today, like how critical do you see offshore wind actually compared to other renewable options on a global scale? Like what's the role of offshore wind in the energy transmission?
I think offshore wind has 2 or 3 major advantages. First, existing oil and gas industry offshore can actually transition to offshore wind. That happened already in Scotland. So you have the equipment, sort of the ships, the tugboats, the workboats, the submarine, the remote control submarines. All those working equipment can be almost entirely recycled for offshore wind. There's nothing new. So you can actually use the same workforce, which also provides a lot of acceptance for this technology. Secondly, you can even place them where offshore oil and gas used to be. So the idea for North Sea, for example, always was oil and gas industry out of the North Sea, wind industry in, not on top of what oil and gas already did, because in the North Sea alone, there are 450 oil and gas platforms, plus almost more than 1,000 kilometers of pipelines. You don't want to add another thing. Yeah. That's one thing. The second thing is offshore wind is basically the workhorse for the electricity supply. It's almost base load. It's big load. So offshore wind supplies the industry. That is nothing for residential area. That's the industry. You have very reliable capacities in a sort of bulk volume. So I would say offshore wind is key to supply security of supply and to supply the industry. And offshore wind is not more important than solar, and it's not more important than onshore wind. They're all very important and have different roles, and they add up to each other. So that's basically what I see. And also it gives us a possibility to leapfrog into large quantity.
Yeah, okay, understood. Thank you. Peter, do you have a question, or shall I look first at the question in the chat, because there was one?
Well, I might just make a couple of comments. Sven's dealt magnificently with the technical challenges, the opportunities, and things like connectivity to onshore, which is vital. Just a couple of points that make this more complicated is the regulatory and governance complexity in Australia with 3 layers of government, and you don't get from offshore to onshore without multiple agencies being involved. Our lack of knowledge of our oceans around the country. There's a concerted research effort going on, but we know very little really in toto about our ocean floors, in particular if we're looking at site impacts. And there is a long history of, as Sven said, of oil and gas here, not necessarily in the same regions. Gippsland, yes, but some of the other more favourable routes for offshore wind are not those that have been, well developed for offshore oil and gas. So things like site impacts are important. And then there's the other thing is seascape impacts of things like migratory routes, etc. So they're all kind of sizable issues that, that'll need to be worked through. The other last comment I'd make would be the social license for this too, because any new technology faces some resistance, and that's another hurdle for companies and for the sector to overcome. I'll just make those points because the other opportunity for us is there's a huge amount of learning, particularly from the North Sea, and so a lot of that is translatable here, and we could learn a lot from the European experiences in offshore wind. So I just want to make those points. And IUCN has been working with a series of industry partners and through Ginger and other partnerships to develop a series of initial guidelines for the siting of offshore wind, for the responsible sourcing of materials for offshore wind installations, etc. So there's a body of work that's growing that is available and will be available and further developed to help with this transition. So if I could just make those points before we go to the questions.
And maybe I can just jump on one of the points you made, because one thing we also talk about here at Ginger is people positive, and so far there is no offshore wind in Australia.
Mm-hmm.
But are there already protests against it? How do I have to picture this? And because at least there's a lot of skepticism, as you say, also because it's not known that there's renewable energy deployment in the sea. Like what lessons, Sven, maybe can we take from Germany, because you've been here before and you've seen what happened here, to maybe also convince people and the communities on shore, on the land, who will then also profit from this.
Yeah, so as I said, I'm originally from the North Sea. I'm sort of grew up near Friesland, and the Frisian people are globally well known for their cow breed. It's the black and white cows. That's from us, but they're also known as extremely stubborn. So when offshore wind came first, nobody liked it, and especially the coastal communities, the tourism industry went sort of crazy. They didn't want this. And there was at least a 5 to 6 year debate with local people to actually first bring information. So what we really need, and I have been at an information evening in the Illawarra, south of Sydney, about offshore wind. And the problem I saw was that the level of information offered to the local people was actually really bad. So the people asked questions, and the presenter couldn't answer 80% of the questions. So that is a really good way of basically turning people away from that. So you need good information. You need also visualization. You need to have sort of mock-up plans. How does it look if I sort of go offshore? I see the coastline. Do I see the wind turbines? Yes or no? How big are they? And stuff like that. I think that's really important to get the people on side. You can't actually do that against the people, because at the end of the day, you're usually dealing with coastal people who should be involved in operation maintenance. So talking with people is probably key. And then legislation that was also in Germany. Germany has no offshore oil and gas industry. There's only one gas platform. So there was zero legislation, and same situation as in Australia. Sort of the beach was council. The next 3 miles was state, and then the rest was federal. And usually they had all different governments. So we had social democratic there, we had the Greens there, and we had the Conservatives there. They, by definition, don't like each other. So you might have a grid connection from the council and one high sea, but the 3 miles in between, you have no agreement. So that really doesn't help. And that took another 7 years in Germany, and I hope Australia will not take 7 years to overcome that.
Yeah, you said 2030. That's still quite a long way in my eyes.
Because it's 5 years.
But looking at the climate targets, I think we need to move quicker.
Well, it's 5 years, and we don't even have a single installation facility boat in Australia. So you need special ships to install them. We don't have a single one. So we really need to sort of get going.
Okay.
There
Maybe
is one opportunity there, though. Some of those renewable energy zones offshore have been sited near, as you point out, areas of current large-scale electricity generation, coal. And as they wind down, you've got workforces and infrastructure there that can transition to alternatives. And there's an opportunity there. So it doesn't necessarily be just all a barrier and uphill. There are some potentials. Can I just also note in the chat that Shulin has posted links to those guidance documents that IUCN has been working on with partners that are aiming to help some of the issues, talk through the issues that we've been just raising. So
yes.
Thanks, Annika. We should go to the chats.
Yeah, and I saw that Oiberto, if I say your name correctly, Likayan from the Philippines, you have several questions. I'm a bit lost on your first question. Maybe you want to jump in and unmute yourself and ask a question in person if you want. Feel free. Otherwise, so can we include sustainability in food science and climate impact, as well as renewable energy applications in agriculture and electrification, and then as well as ocean ecosystems? So basically all in one. Maybe can you specify your question a bit? Are you still there? Okay, maybe not. But because I think you specify at the end, are there possibilities of offshore wind protecting ocean ecosystems? So this goes into what we call nature positive, to only build infrastructure in a nature positive way. Have you had considerations around this in your research, or is this not basically touching?
I mean, I think Peter is better positioned. I think I read and heard ideas about fish farming and artificial reefs, but that is so not my area of expertise, and I know it's quite controversial, especially fish and salmon farming. Salmon farming is a very emotional topic in Tasmania. I wouldn't even go there. Yeah. Yes, you can, but it depends really on the ecology.
Maybe I can just refer to what our colleagues here at RGI are doing at the Offshore Coalition for Energy and Nature. We have an impact report, and we have also graph pictures on nature inclusive design ideas. If I can, I will drop the link. So Alberto, you can have a look at what our colleagues at Ocean are doing, and there are some interesting publications that might be interesting to you. Then Mark, you asked, very interesting presentation. Thank you. Interested in your thoughts on what are the main challenges for currently planned offshore wind projects in Australia. So yes, why is it not happening faster? Is this, as you said already, depending on the regions, the ports, the ships? Are there possibilities so that we can, like on a global scale?
I would say what Peter said already, it's the lack of the legislation, because it's a new technology, and it's not that there's legislation against it. There's simply none, and we need to develop that. And I think that is currently the main obstacle, because once there is a clear commitment, which I think from our new government, we have a good commitment. We need now the policies, and then we have investment certainty that investors actually move ahead and invest money in whatever we need, the equipment, also manufacturing equipment, ships and stuff. But no one would invest $1 billion if there is no clear legislation. I think the main obstacle right now is that we have parts of the legislation already in place, but not everything needed. And that's basically what's the main bottleneck.
Do you know by chance if there are already exchanges with the European Union, with places like Scotland, Germany, so that there can be lessons learned from the North Sea on this?
I honestly don't know what the government level does. I assume they will. I'm pretty sure. I mean, Australia is very deeply connected to the UK, obviously, and the UK is one of the largest offshore wind areas in the world. So I assume that there are exchanges on government level, but I'm not involved in that.
Okay.
Yeah.
So yeah, fingers crossed. I see there's one new message here. Thank you. Okay, that's we're on spot on time. Thanks, Sven. Thanks, Peter, for joining. We will have this webinar online, so you can share with your audiences. We also have other webinars already recorded from the last 2 weeks. You can all have a look on the Ginger website. Yes, thanks again for joining in this heat, in these high temperatures here in Germany. Peter, have a very good night.
Thank you. Thanks, Annika. Thanks, Sven.
I really enjoyed it. I learned a lot. Sven, we will be able to share the slides later, right?
Yes, yeah.
So much. So we will put these online as well. And thanks for all your interest, and see you soon, maybe at some other webinars.
Thank you.
Bye-bye.
Bye.
Bye.